Google that. How am I doing for time? Okay, not bad. I think I have some time. So the next piece is Spark. Okay, so let me tell you, everything I told you about MapReduce and Hadoop, you can just forget all that. It's not going away, okay? But I would say that what Spark is a different project. It's often combined with Hadoop, so you'll see it included in distributions, but it doesn't actually require Hadoop. But often the combination of Spark and Hadoop is pretty powerful, but is not necessary. And Spark also has an implementation of map and reduce functions, and actually much more than that. And it can do all sorts of things, and it does it all with the ability to exploit memory. So I'm going to do a demo for you, what it looks like. Let me just kind of summarize, though. So Spark is this really fast-growing general-purpose engine for large-scale data processing. I'm going to read this to you. It is faster, and because the way MapReduce works is, in the map phase, we read the data, we write some intermediate results, we write to local file system, then there's this kind of shuffle, and then there's this reduce, and we're reading files again. After reduce, we write files again. So there's a lot of I/O involved, right? Reads and writes between the different stages. With Spark, it can actually read the data once into memory, and then kind of pipe the data around in memory between what we call executors. And so by exploiting memory more efficiently, exploiting memory period, it's able to speed up programs 10 to 100 times is not uncommon, depending on that complexity. And then it has three primary application development environments: Java, Scala, and Python. My personal preference is Python. I can read Scala, okay. It's just personal preference, really. Okay. So what is it? What is it? So there's this thing called Apache Spark Core, and this core has the whole architecture, that runtime that is Spark. And what's neat about Spark is this kind of this engine that can optimize data flows. How do I simplify this? And through extensions to the core, you can have something called Spark SQL, Spark Streaming, Machine Learning, and GraphX. And actually, it's all the same thing. It's just different interfaces to the same core. And so, for example, what's neat about Spark then is I can kind of build pipelines, or I can, as long as I can get data into this thing called an RDD, or a resilient data set. If I read from a file, read from some kind of incoming stream, read from whatever into this RDD format, it's just rows and columns, essentially. I can now manipulate that in a common format. So I can move between these different domains of analytics in a single framework. And it's all exploiting memory, and so that's what makes it really powerful. And you could have a choice of running standalone, cloud, Mesos, Hadoop. You use Yarn as a resource manager. If you have, the idea of having Spark on Hadoop is that, well, Spark can scale out to multiple nodes too. And just like how MapReduce abstracted the cluster nature of the system, Spark also, I work with Spark writing my scripts. I don't have to think about how many nodes are behind. It just kind of does it, right? But if I have these nodes stood up with Hadoop, why don't I just run Hadoop and Spark together over the same hardware? And that's just the basic thinking, right? It can connect out to all sorts of different sources. It's just kind of a general purpose framework. So I called it a next generation analytics fabric, right? So performance tests, showing, I don't know, these are just benchmarks, I guess, for machine learning and what's that, page rank, right? So you can see the lower bar is better, elapsed time. So you can see, dramatic speed ups in time. And the kind of workloads that really benefit from Spark are the ones where we read the data over and over again. Because we pay that price once to read from disk into memory, and then we have the ability to cache it and reread it over and over again to do whatever kind of analytics we're trying to do. So my suspicion is that Scoop uses MapReduce, right? The traditional Java kind on Hadoop. My suspicion is that if we rewrote Scoop to be Spark-based, I would get zero benefit. Because it would map that task out, each of the nodes would connect to the remote database, pull the data over, land it on disk, and I'm done. Well, where's the speed up in that, right? But if I read the data over and over again in memory, there would be a speed up. So I'm pontificating, whatever. Anyway. Oh, good question. It's really
We're
configured.
talking about they hold the information to the memory, right?
Yeah.
So since Hadoop is they hold large amount of the data, right? So
Yeah.
in order to do this, right, you need a chunk of a memory.
Yeah.
You
Yeah.
still
Yeah.
do the page tree.
Yeah.
It's
So-
an advantage.
So the data nodes that I'm seeing being built by at least corporate customers, they typically are 64 gig minimum, commonly 128 gig minimum, up to 256 gigs or more per node. And they may have 100 of these, right? So there's a lot of memory in the platform. And memory is getting cheaper, that's one thing. And also it's, if I want, I'll just get more out of the platform with more memory. And so, so you're right. So Spark does, can take up, you can run a job that takes up a lot of memory, but there's a lot of memory to go around. But also we did a benchmark with the IBM SQL engine for Hadoop versus Spark SQL. What we found was that, on single stream, especially on the simpler queries, they were very similar performance. But when we get into high concurrency, that's where Spark SQL starts to break down because each of those queries starts to use up lots of memory, right? So there is some active work in memory management for Spark to make it better, but I would say this is me, not IBM, not anyone else, okay? But my experience has shown that Spark workloads are not conducive to super high concurrency if you are used to relational database systems. If you're used to an enterprise database system, hundreds of users, thousands of users, no big deal, right? Try doing that with Spark SQL, it's kind of not really going to work. You might get a few dozen concurrent queries at a time that are complex. So that's just, Spark is fast for certain workloads. Again, choosing the right tool for the right job, okay? And by the way, when people talk about Spark, there's an automatic associated with Spark and fast. I want to tell you that Spark is really fast compared to MapReduce. I want you to remember that, okay? And Spark will continue to get faster, but where Spark gets its reputation from is much faster than MapReduce. SQL piece, I have a bit of a database heritage, so I have a bit of bias, but it's Spark SQL is coming along, but it's not there yet at replacing. It's not ready to replace data warehouses. Let's put it that way. There are many people who are trying. So lots of activity. So why are we excited about Spark? When we compare, lines of code changed and commits, right? Commits are like a measurement of code changes in the open source. You can see that Spark has been really, really busy, very, very busy compared to even Hadoop, right? It's actually outshadowing HDFS, Yarn, and MapReduce. And so lots of growth, lots of excitement on what they can do, to the point where IBM is investing very heavily in Spark. So, IBM to invest hundreds of millions in free data technology. We're going to train 1 million data scientists or analysts in Spark, right? Well, guess what? All of you guys here, you're here because of this program, right? Because we committed to educating the public on how to exploit Spark, how to explore Hadoop, and those kinds of things. So, we are investing in exploiting Spark and Hadoop. We donated something called SystemML, which you should be aware of as well. So there's a project out there called Apache SystemML. That was donated by IBM. It stands for SystemML, stands for machine learning. And this is the ability to do machine learning at very large scale. So the ability to take a machine learning algorithm and actually, we're good typically at running them on single nodes, but there's complexities in running them across multiple nodes. And so that is now open source. We gave that to open source for the purpose of integrating with Spark, okay? We have this thing called the Spark Technology Center, which is really cool. So there's a building full of people in San Francisco who do nothing but Spark, just to make Spark better. And we call that church and state. So state, right, government, is IBM. And then Spark Technology Center, they're church. We're not allowed to mix them. They are actually independently funded, and they just get earmarks, and they're just doing work for the good of Spark. And so we call this idea of separation of church and state. Of course, they're working on things that we mutually believe are important, but we are donating to Spark through the Spark Technology Center, and they have a mission just to make Spark better for everybody. Okay, so let me show you a quick demo, and then I'm going to wrap up with cognitive computing. We talked about big data, right? Okay, are we all going to just pile through this data and try to make some sense of it. Well, we think there's a space for cognitive, okay? And so we have this thing in IBM, which is that we define these eras. You know, when IBM was making these machines, tabulating machines, they're more mechanical, you know, punch cards, that kind of stuff. That's the tabulating era. There's programmable era where there's more software. We're actually writing and coding stuff. And then the last thing is 2011. Does anyone know what happened in 2011 that we would declare this a cognitive era? Watson and Jeopardy, thank you. So look at this. This is not every few years, right? This is a 50-year gap, 50 or 60-year gap. So we kind of consider these as really big evolutionary steps in computing. So yes, in February 14, 2011, I know exactly where I was. I don't know if you guys know where you were, but you know, Watson was able to beat these two Jeopardy champions. And what was so special about that was that they're able to take a question in natural language or an answer and give back the question. Is the natural language processing piece that was interesting. And so now we've taken that thing and actually productized it into this thing called Watson. And we're helping companies like Memorial Sloan Kettering to actually, we're positioning Watson for healthcare. We think that we could do really good things with cancer treatment and other, you know, help advance biomedicine and treatments.
Sloan Kettering is one of America's first cancer centers, and our mission is to care for people, but also, as part of the process, always looking to find a better way to do things.
But the massive amount of data that we collect is difficult for any one person to analyze.
So having the information and the wisdom at your fingertips is going to basically make every doctor the most experienced doctor in the world for taking care of that particular problem.
The partnership between Memorial Sloan Kettering and IBM Watson is really at the forefront of our ability to deliver evidence-based medicine through analytic approaches to understanding cancer as a disease.
What our role is that we are MSK Watson's teacher. And just like we would teach a trainee in medical oncology or surgical oncology, we're teaching the MSK Watson system. One of the ways that IBM Watson won Jeopardy was that it was fed in a lot of prior Jeopardy questions and answers, and it learned the correct way to answer those. In essence, MSK Watson does the same thing, but the information we're feeding into it is how Memorial Sloan Kettering doctors treated Memorial Sloan Kettering patients.
Watson's capability to analyze huge volumes of data and reduce it down to critical decision points is absolutely essential to improve on our ability to deliver effective therapies and to actually disseminate that information to the world.
It has access to research. It's taught by specialists. It's also taught by the experience of the patients treated at specialty centers like ours. Watson learns from those cases and gives you a list of choices really chosen for you, which is something we've never had access to before.
I think this is beyond an evolutionary step. I think this is a revolutionary step. This has the potential of totally changing the way we conduct medicine.
We need to get our best to other doctors so that patients everywhere can take benefit from that.
Will allow us to design treatment programs and also ways to follow patients that avoid over-testing and to more effectively use a treatment to personalize their therapy.
Now, I'd like to say that there's two parts of any medical problem. There's the biology and there's everything else. What Watson's going to be able to give us is the everything else part, and that's going to make a total comprehensive package that's going to improve results worldwide.
What's interesting about Watson is what defines cognitive is this ability to understand natural language, generate and evaluate evidence-based hypothesis. So I submit a question, it comes back with here's a ranked listing of possible answers based on what I've learned in the past. And if it's wrong, you can train it. They'll say, oh, I was wrong, I'll get it better next time. And this is, you know, a subset of AI. So just to wrap up, big data, variety, volume, velocity, and veracity. You know, Hadoop changed economics for how analytics work for big data. It's not that the big data didn't exist before, is that we now have the ability to actually look at it at a cost-effective manner. Spark is this next generation analytics operating system you should be aware of. And Watson, the future is cognitive. That's all I had today. Thank you very much.